Okay, we're up and running. Welcome everyone. We're going to do a couple of types of problems from 4-5. One is grouping. And this may be relatively new to you. Let's say you have a problem like x to the third plus 5x squared minus 4x minus 20 equals 0. And you are given no roots. What's the problem? What is the problem? Well, on certain types of polynomials. Ani, what were you going to say? Yeah, I know what you mean. Normally with cubics, we're given roots, okay? So this one, we can group it such that we have this kind of a deal, okay? We can say, okay, this we can group as x cubed plus 5x squared minus, now be careful here, if you group them like this, what do I have to do with this 20? I have to make it plus 20 because notice that once I group it, this negative sign will be distributed to both the 4x and the 20. That's kind of a danger, Will Robinson. Be careful, okay? I'm going to put a little note in here. Note sign, okay? I'll even sign change. You know delta, change? Okay. So now, this is what Ani was saying in her eloquent way. She said, factor out, maybe I won't do that yet, factor this, okay? So now we have what can we factor out of here? What's a common term? Common term right here. X squared, yeah. We can say that this is x squared times x plus 5. Okay, now once you get this x plus 5, we're going to say force x plus 5 here. Okay? So whatever you get right here, you automatically have to get on the other side to make this work. So just put an x plus 5 in here and then say to yourself, okay, self, what do I have to multiply times x plus 5 to get 4x plus 20? 4. Yeah, we can handle that. So now let's see if it's the same thing. 4x plus 20, yes. X plus 5, x plus 5. Okay? I'm going to give you just a minute to make sure you're okay with that. Joel, question? Okay. And thank you. Now let's watch. I think I'm going to write this whole thing again. I think I'm going to write this whole thing again to try to help you see. Clone that. Bring it down. Why do we do such madness? Great question, Joel. So let's pretend that this is all in one big gig like this. Yeah? Okay. Now, what can we factor outside of the green? The mean green, what can we factor outside of that? Welcome. Come on down. Just tell me it's true love, Mr. Jennings. Okay, good. Welcome. I'm glad you're here. Okay. See, that's the only excuse in my class for being late. True love. Okay? Princess Bride, yeah? Okay, good. If you haven't seen Princess Bride, do it. It'll change your life. One of the finest films of all time. It's true love. Okay, here we go. What can we factor out of these green things? John? X plus 5, you the man. Right, and Joel, this is why we're doing it. We're going to factor out an x plus 5. Now, this is where it gets weird. What do we have left? Well, we have x squared times 1, essentially. Think of it like that. Minus 4 times 1. Really, that's what we're doing. We're saying, how many times does x plus 5 go into x plus 5? Once. How many times does x plus 5 go here? Once. Think of it like that, and it seems to work better. Okay? Now, we've grouped this in a slightly different way, and we have x plus 5 times x squared minus 4 equals 0. Ooh! Isn't that cool? So we just got ourselves a root. Aha. Well, factor. We will get a root. So then, as we always said, if we have one blob times another blob equals 0, what does that mean, AJ? It's okay. Just think about it. Something times something else equals 0. One of them has to be 0. So we can say x plus 5 equals 0, or x squared minus 4 equals 0. And then we can say x equals negative 5, or x squared equals 4. Then we can say x equals negative 5, or x equals 2, or x equals negative 2. And we just got 3 roots. Bam! And that's pretty cool. Pretty cool. Pretty cool. Well, and that is a trick. That is a trick. No, it's fine. And this doesn't work on all polynomials, but it works on some of them. Okay, they have to have a common term. In this case, this binomial x plus 5 is common in both. And so it doesn't work every time. Camille? Well, when I take the square root of 4, I can go 2 times 2 equals 4. I can also go negative 2 times negative 2 equals 4. Okay? And thank you for asking. I love questions. You have the courage to ask them. Jory? Well, you just got to keep everything right, and thanks for asking. Where was I? If I did not change this to a positive 20, when I multiply this out, I would go negative 4 times x, and I'd get negative 4x, right? And then I'd go negative 4 times negative 5 if I didn't change it, and I'd get positive 20. And I would have a different polynomial then. Because whatever I do to this, however I change it, manipulate it, and move it around and express it in different ways, it always has to represent this original polynomial x cubed plus 5x minus 4 minus 20. Does that help? Right. That's a fair statement. Yeah. That's true. Okay. So I want you all to try one. I'm going to stop the recording for now, but we'll be back. Okay, we're up and running again. So awesome. New topic, second part 2, let's call it. Solving by quadratic form. Okay, and this is the one I wrote down earlier, and y'all were freaking out because we hadn't done it yet. So let's say you have something like 2x to the 4th plus 2x squared minus 4. Okay, you look at that, you're given no roots, and you panic, right? Well, yes, you should, but it's okay. So I'm going to say, thank you, Delaney, let u equal something. Notice that this is x to the fourth. There's no cubic term. This is x squared. There's no linear term. So let's recognize this is in quadratic form in disguise. And you probably can't see it yet, but let u equal x squared. Okay? So let's think of this as 2 times x squared plus 2 times x squared minus 4. So now, watch this. This is cool. I can go over here, and because I have an x squared, I can write this as 2u squared plus 2u minus 4 equals 0. I left off my equals 0. And now, what kind of problem is this? It's quadratic. It's a quadratic. You can just plug that in your calculator, or you can factor it. I always try factoring first, but if you don't have that, just use your program. What would I put here and here if I'm dealing with 2u squared? 2u and 1u. Yeah, thanks, Rodney. Okay, 2u and 1u. And then I look only at the 4. I look only at the 4. What are the possible factors? 2 and 2 or 3 and 1? 1 and 3, that's what you're going to say. Same thing. So, and we may get it wrong, and that's okay. Put in 2 and 2. I look only at the negative. What does that mean? One's negative, one's positive. I look only at the positive. Means the larger one's positive, so I'd have to go there because I'm going to go 2u. And now I check this. I go 2u times 2 is 4u minus 2u. Does that work? Well, if you can't remember, just check it. That's fine. We can go 2u minus 2 and u plus 2. And I get 2u squared. And I get minus 2u. And I get 4u. And I get oh, God, that's ugly. My handwriting is so bad today. U plus 2. And I get negative 4. And it does work. Okay? So that means then that what? Jesus, question? Javier? Somebody else has that same question. Come on. You're okay? ¿Está bien? Okay. So now we have 2u minus 2 equals 0, or u plus 2 equals 0. Okay? And then what? u equals 2, or u equals negative 2, correct. And then u equals 1, or u equals negative 2. Now, remember to substitute back. Okay, what did we start with? Yeah, u equals x squared. So now we have to say x squared equals 1, or x squared equals negative 2. Almost done. Right, exactly, because there's 3 roots. Who said that? Rodney, very astute. That was awesome. Okay, next up. What do we do? John, help me. Okay, square root both sides. Okay. 1, -1. Well, let's write it. Let's do it in steps, and it's not so bad. X equals the square root of 2 times the square root of -1. Let's do it that way, and then it's not such a, painful thing. Okay? So x equals plus and minus 2 square root of -1. I. Thank you, Jory. So now there's our 4 roots. X equals 1, -1, 2i, -2i. Because we started with what kind of polynomial? Way up here, x to the 4th, how many roots do we have? 4 roots. So we have 2 real roots and 2 complex roots. John? Oh, okay. Thanks for asking. Let's back up just a little bit. I need just a smidge more room here. Oh, did I goof? Square root of 2. Oh, I just left off the square root. Thanks. You're so right. It's just square root of 2i. My bad. Thank you, John. Thank you, John. I just left off the radical sign. Yeah, and that's fine. And the i's not under the radical. That almost looks like it is. I'm going to move it over. Okay. Oh, man, I feel good. I think I'm going to stop here. Let's see how far we're into it, and I'll give you an example. 17, that's about right. Cool. Thanks for listening.